7.3, proving triangles similar. So just like we have shortcuts to proving triangles congruent, we also have shortcuts to proving triangles similar. And that's what we're going to go over today. However, when we're talking about similar triangles, we're talking about proportional sides and congruent angles. Proportional sides, not congruent sides, proportional. First one that we have is angle similarity. That's how I would write the shortcut for that. And that's saying if we know two angles are congruent to two angles of a different triangle, we know the third angle has to be congruent. So then we can have three angles congruent. And how do we know the third angle is congruent? Because 180 minus this amount will be the same thing as 180 minus this amount. Where do I get the 180? All the angles in a triangle add up to 180. So using the angle postulate. So are these two for A triangle similar? If I look at this, I only have one angle. However, just like when you're talking about congruent triangles, you should also, in similar triangles, you'd also look for x's. X's will give you vertical angles. So that means this angle and this angle are congruent. It doesn't matter what they are, those two would be similar by angle similarity. So the next two triangles, at first thought you might think, no, they're definitely not similar. However, to make sure they're not similar, you always want to find out what the third angle is. So I'm going to use 180 minus 70 minus 30. Now I get that this angle is going to be 80 degrees. And if I did 180 minus 85 minus 70, I would get this angle is 25 degrees. So now I can clearly see that no angles, or no two angles are similar or the same, so no, these are not going to be similar by angle similarity. And the last one, it looks like I have two congruent triangles. So for this triangle, I know my opposite angles are going to be congruent, so this automatically is 68. So what I want to do for my second triangle is figure out what these two angles are. How am I going to do that? Those two are going to be the same because this is also an isosceles triangle, so I know x plus x plus 62 is going to equal 180. So then I have 2x plus 62 equals 180, subtract 60. I get 2x is equal to 118, divide by 2, x is equal to 59. So again, these are not similar because I do not have an angle similarity. Because both B and C here would be 59 degrees, which is not two angles equal over here. And then our other two shortcuts would be side similarity and side similarity. So when we have these two shortcuts, you have to make sure the sides are proportional. Proportional, not congruent. Angles would be congruent. So I'm talking about the side, it's still going to be in the same format as this side, angle, side. So you still have to be able to trace out the triangle and figure out what is given in your picture. Are the two triangles similar? Well, if I look at the two triangles, I have one big triangle right here, and I have one small triangle right here. Since there's an overlapping angle, I want to try to solve this by side, side. I'm looking to see if these two are going to be similar by side similarity. I already know that angle K is going to be congruent to itself, so I'm just going to write that in. So now I want to see is KM, that's my large, over KL, because those are the side that kind of overlaps. Will that be congruent to KN, because that's my large, over KP? So when you write up your proportions, KM is the total length. So this total length right here is going to give me 10. KL is 8. And KN is the total length, so that's 15, and KP is 12. So I'm going to reduce each fraction. So the first one, both of those can be reduced by 2, so it'll be 5/4. Second, both of those can be reduced by 3, so it'll be 5/4. So yes, they will be similar because of side similarity. Again, sides are proportional. This one's a little bit different. First, I see that I'm given 3 sides, so I'm going to try to use side, side, side similarity. Now, if you look at the 2 pictures, they're not drawn exactly the same. So what you want to do when you're matching up your proportions is look, okay, which one's my largest side of my smaller triangle? So that would be 10, and which is my largest side in my larger. So I'm going to have 10 over 15. And then what's my second largest would be 8. My second largest would be 12. So I want to see if that's going to be equal to 8 over 12. And then my smallest is 6. My smallest is 9. So I want to reduce those all to see if they're going to be the same. First one, both of those can be divisible by 5. That's going to be 2/3. Second one, both of those can be divisible by 4. So that's going to be 2/3. Last one, both of those can be divisible by 3. And that's going to be 2/3. What? They're all the same. So yes, it's going to be side, side, side similarity. Indirect measurement, I would not write this down. Indirect measurement is just something that you have to realize when to set up a proportion. And usually it's going to be with word problems. When we have a proportion, an example would be, I always tell people to start with fraction bar equal fraction bar and then fill in your information. So if I was talking about, let's see, say a shadow, I would label this fraction shadow. And if I was talking about height, I would label the other fraction height. Now, a lot of word problems when I'm dealing with shadows and height might be a flagpole, so I would label the top a flagpole, and the bottom could be a person. So then when I say in the word problem, Susie is 5 feet tall, so that's height, so I'm going to put 5 feet tall, and she casts a shadow of 2 feet, so I would write that under person and shadow, and the flagpole's shadow is 33 feet, I would write that where the shadow for the flagpole. What's the height of the flagpole? I would put an X. So when you're doing indirect measurement, it's very important to know what you're labeling for your fractions. And then once you have your proportion, you can set it up like normal and do cross multiplication. So in this word problem, talk about 2 different things. And I always tell people to start with a fraction bar equal fraction bar. When I'm looking at this picture, I have 2 things I'm talking about. I'm talking about a cliff. I'm talking about a person. There's also 2 different things I'm talking about. I'm talking about height. I'm talking about with the mirror on the ground. So when I'm looking at my numbers, this number right here would be the height of the person. Height person, I should make sure to line that up. Here's the ground of the person. So ground person should be 6 on the bottom. Here's the ground of the cliff. So ground cliff should be matched up. And I'm looking for the height of the cliff. Right now I want you to pause the video and see if you can figure out how tall the cliff is. You should have gotten that the cliff was 31.2 feet tall. You always want to make sure to have units when you're talking in a word problem. Again, I want you to pause the video and see if you can set up a proportion for the next word problem by yourself. This is what your proportion should look like. And again, I labeled because then it's easier to plug in my numbers. Now I want you to make sure to solve this by yourself. If you just have this answer in 150, you will not get full credit. When you have a word problem, you should make sure to label your units. So the oak tree would be 150 feet tall. And that is all for today, folks. Have a wonderful evening.